Right, here we are in chapter 21. We're playing with cubic functions, circular functions, exponential functions, and there's one more I can't remember, but we'll come on to it. Oh yeah, inverse reciprocal functions. We'll come on to that as well, although that's not in the original title. Right, 21.1 is just the cubic functions. Now, about these wonderful cubic functions, you've been used to quadratic functions, quadratic equations, where you get graphs, looking a bit like that. So that might be y equals x squared plus, 4, or graphs like this. That may be y equals x squared minus 2x minus 3. I mean, I'm completely guessing here, right? So that's what we've been used to. Now, with these wonderful cubic functions, please note there's an x cubed there, and the most basic cubic function is this one here. Let me just try and draw it for you. Right, it looks a bit like this. There's no kinks in it whatsoever, no bends, it just turns like that. And that is a classic shape of y equals x cubed plus nothing else at all, right? So that's y equals x cubed, looks a bit like that. You might have met it in Key Stage 3. A graph like this would be, y equals x cubed plus, whatever the intercept, y-intercept would be there, perhaps 4. And an x cubed graph that might cut the y-intercept as follows might have an equation of y equals x cubed minus 6, for example. But once you get these like double humps here and here, we have more of a complicated equation. Look at this one. Y equals x cubed minus 2x squared minus 8x. That's very, very involved, isn't it? So, but still the essential shape of up, round and up persists. So you're looking for a shape that looks like this rather than a U shape or an upside down U shape in the case of a minus x squared graph. So that's the first one I'm introducing you to. And it says write down the coordinates of the points where the graph turns. So where does a graph suddenly turn? So up we go. Oops, let's just rub it out. So up we go. We peak around there. So I'm going to label that coordinate in black so it stands out. So I'm going to turn there. I'm going to turn about here. Just don't name the coordinates. -1, 5, I think. Not perfect, but that's the best I can do just by reading it visually off the screen now. That's that one. That's a turning point, and the other turning point looks like between 2 and 3. So I'm going to go 2.5 for the x value, coming down to minus not quite 17. I'm not sure. I can't really judge it. Maybe it is. Yeah, I'm going for 17, or rather minus 17. So these are the two turning points. The graph turns there at -1, 5, and turns back up at this point here, which is 2.5 minus 17. Full stop. That's it. Use your graph to solve the equation x cubed minus 2x squared minus 8x equals 0. In other words, y equals that equation, and of course y equals 0. Now, as you know, y equals 0 is the x-axis here. Just to remind you, that's that. So we need to read off where the graph cuts through the line y equals 0 or the x-axis. Now, being a cubic equation, you can get 3 answers to this. In fact, you will get 3 answers to this if it cuts through the x-axis. So solve the equation. Now we want just the x value. So first of all, there's an x value right there. That's -2. So x equals -2 when y equals 0. Here I've got, look, cross through the point 0, 0, so x is therefore 0. So x equals 0 when y equals 0. And the last one's right there, very clearly to see, just there. X equals 4 when y equals 0. So these are 3 solutions. Unlike in a quadratic, there's 2 solutions there, and there's no solutions there. It doesn't cut through the x-axis. So that's an introductory question. So what do we got? Learn the shape. Here we are. This sort of arrangement. Or this sort of arrangement. So if it's negative, it's going to go like this, say. That's the axes there, etc. And we recognise that some of these things can have 3 solutions if they cut in 3 places. In fact, they will all cut in 3 places, unless of course it passes through the point 0, 0, in which case there's just 1 solution. Okay, so get the shape and get the 3 solutions in your head. Next one. This is question 2 by the look of it. The diagram shows the graph of y equals x cubed minus 2x squared plus x minus 3. A little bit more complicated. Again, up, little kink, and round and up again. So we're still getting this pretty little arrangement like that, aren't we? Okay, that's what we're looking for in an x-cube type graph, a cubic graph. So use the graph to solve the equations. This equals -4. In other words, if y equals that equation and y equals -4, I've got to draw on the line y equals -4. And we've been given the hints here anyway in the textbook. So y equals -4. Let's just draw it in. Well, I usually do with my facility here. It's not very good. That's brilliant. That's the line y equals -4. I mean, I know you know that. So where does it cross? Round there. I've got to try and read up, which is really, really hard. I reckon it's between 0 and -1. So I'm going to go for x equals -0.5 or -1/2. So solve the equations. In other words, what is the x value or values where the graph cuts, where the graph of y equals, well, this graph here, where that graph cuts the line y equals -4. Answer, just one solution, it cuts in one place. So I'm looking at, let's have a look, a solution of -0.5 or -1/2. One answer. Again, x cubed minus 2x squared plus x minus 3 equals 0. Look, y equals the equation and y equals 0. Now here's me saying, in the previous question we've got 3 solutions, but here look, the graph only cuts the line y equals 0 in one position, right there. So there's one answer only. Okay, so just go back to remind yourselves. Look, 3 solutions for this one. 1, 2, and 3. Bam, bam, bang. There they are. This one cuts just in one place, and there it is. And it looks like one square after the 2, so I'm going to go for 2.2. It goes 5 squares in each unit. So I'm going to call that x equals 2.2. I could call it x equals 2 1/5. Don't have to, it doesn't matter. I could call this 0.5 or -0.5. Alright, so that's that solution. And here I've got, again, y equals that equation, and in order for y to equal 4, to make the two equations equal, they're going to intersect somewhere. So we're drawing the line y equals 4, and there she is, straight across there. Label it. You know it's y equals 4. And again, look, one solution right there. Now I've got to try and read that thing down, and let's try and at least show this one on the graph, or about there I suppose. And right there, that's between 2 and 3 I'm guessing, so I'm going to go for 2.5. Right, so when y equals 4, we have the solution of x being between 2 and 3, 2.5. Again, that's not perfect, but it's the best I can do, and I'm genuinely using my graph. Alright? Now, depending on the next question, if it gets too complicated, I might do it as a separate video. We'll have a look, shall we? Come to a decision. Oh, not too bad. Right, let's get another one. This is question 3. It says the diagram shows the graph of y equals x cubed. Again, look at this beautiful up, down and round. So a lovely little kinky shape there. So y equals x cubed plus x squared minus 2x. There we go. So here we go. Right, use the graph to solve each of these equations. So x cubed plus x squared minus 2x equals 1. In other words, I'm looking for where y equals 1. So the line y equals 1 is straight across there. Now this is a good one. I'll tell thee why it's a good one. Because it's going to cut this graph in 3 places, and therefore there are 3 solutions. Alright? So let's just write them all down here. Let's start with this one right here. I make that minus 1.2468. Oh, it's really hard, this. Or I reckon it's 1 square before the minus 2 the minus 2, so that's going to be minus 1.8. So I'm going to go for x equals minus 1.8. And I'm going to go for this one right here, which is 3 squares to my left. Oh, so this is really hard. 0.2, 0.4, 0.6. Oh, I don't know. 0.1. How about 0.4? I don't know. I've got to have a. Let's try. I'm finding it so hard. I'm just going to read it down here and make a judgment on that. Right. Put a little arrow on that. So that's 1 and that's 0. I'm going to make that minus 1/2. I think it's roughly halfway. Again, just judging off the screen. So x equals minus 1/2 or minus 0.5. And the last one doesn't look too bad. So let me just try and draw it in. Whack it down there like that. And I make that. That's 1, that's 2. That's about 1.2468. Yeah, that's clearly 1.2 to me. So x equals 1.2 is positive. There's the three solutions for that one. I may need to, of course, rub all this out just to make space for this, but I think I'll be okay. And look at this one. Y equals x cubed plus x squared minus 2x equals 0. In other words, I'm looking for where y equals 0 to make the two equations equivalent. Where are they equivalent? Well, they're equivalent here, here, and here. In other words, at these 3 points, the equation of this cubic graph is equivalent to the equation of the line y equals 0. And it's already drawn for us there as the x-axis, of course. So this is quite easy to read. One solution is x equals minus 2. The other solution is x equals 0. Look, pass through 0, 0. And the other one's dead easy, crosses through x equals 1. Why couldn't that have been first? I don't know. And now, look, same equation, but I'm looking for where y crosses minus 1 to make the two equations equivalent. Let's draw it in because it usually helps to see what's going on. So let's label that equation as normal, y equals minus 1. So 3 solutions then. Reading up, one solution, it cuts in one place, so right there. So let me just try and do that and read that for you. I think it's 1 square after minus 2, so I'm going to go for minus 2.2. Just one solution. X equals minus 2.2 or minus 2 and a fifth if you're interested. Stick to one or the other, it's just that, you know, they're interchangeable in my mind, so I'm writing both down. You just go for either the decimals or the fractions, but not both. It's a pain. Right, so let's just make sure I've not made a mistake. Right, for y equals 1, 1, 2, 3 solutions. Yep. For y equals 0, 1, 2, 3 solutions. And for y equals minus 1, just one solution there. Because look, we have a turning point here, and therefore it doesn't touch the line y equals minus 1, hence just the one solution. And as an introductory video, I'll stop there. Remember, funny shape that goes like that. And it can be 3 solutions, 2 solutions, 1 solution, depending on where the turning points are. And that's it. Right, next time we get a little bit more tricky, I'm sure. And I'll catch you later.